Another very important piece of hardware that we're responsible for are storage devices, and they're arguably just as important as servers, mainly because they're usually attached to them. In this nugget, we're going to look at the many types of storage devices available to us, like HDDs and SSDs and DAS and NAS and SAN, and we'll also look at the technologies that drive these storage devices and where they fit in our network topology. Let's begin with the most common types of storage devices that you'll find in everything today, from desktops to laptops to even servers. HDDs, or hard disk drives, have been around forever, since the 50s, so these babies are ancient technology, 60 plus years, and still widely used today. These are also referred to as magnetic or mechanical disks, and that's because it uses magnetism to store data on a rotating platter. They're big and slow compared to SSDs, but the major advantage is that they can store a large amount of data cheaply, and that's why they're still around today. On the other side of the equation, we have solid-state drives, otherwise known as SSDs. This is flash storage that contains no moving parts whatsoever, as data is stored on these microchips. Now, a common configuration you'll see in most desktop and laptop computers today is to use a combination of both of these. Use an SSD for your system drive that will contain your operating system and any installed programs and applications, so those things boot up instantaneously, and then use an HDD for everything else, all your other files and data. And by the way, these are also collectively known as locally attached storage. Switching gears to more business level storage, we have three of them: direct attached storage, network attached storage, and storage area networks. Let's start here with direct attached storage. Now, direct attached storage, or DAS, is a nice low-cost, low-maintenance solution where our storage subsystem is either a part of or directly attached to our servers. This could be anything from a stack of HDDs and SSDs inside of the machine or in its own enclosure externally connected to the machine. Direct attached storage is great for small businesses that do not have the IT staff or the budget to handle these more complex storage systems, such as network attached storage and storage area networks. The downside with direct attached storage is that it's not very scalable, which is a fancy word for I need more. Because as businesses grow and we continue to add more users means more data, and it means we need to be flexible with our storage systems so we can expand them on demand. Next up, we have network attached storage, or NAS for short. This is where we move those storage subsystems directly onto the network and connect it directly to our Ethernet switches. These guys are dedicated to file sharing and storage and are packed with all the bells and whistles to support it. For example, one of the biggest reliability features built into these is something known as RAID, and it's supported at the hardware level. RAID stands for Redundant Array of Inexpensive Disks, and essentially what it does is protect us against data loss if we were to lose one of those disks to a failure or a disaster. If something bad were to happen to a disk, all the data on that disk is already spread around in little chunks around all the other disks, so it can easily rebuild that data in the event of a failure. And by the way, you can still implement RAID with direct attached storage, but it's done at the software level in the operating system itself, not at the hardware level, so it's not quite as reliable. The benefits of network attached storage are, number one, they're reliable as we just saw, but number two, they're scalable. These enclosures make it very easy for us to add and remove drives on the fly. The downside of network attached storage is that they are directly connected to our Ethernet networks, which can result in network congestion and clog up those pipes for everybody else. And that brings us to a storage area network, or SAN for short. A storage area network gives us the best of both worlds: the performance of a DAS with the scalability of a NAS. In this architecture, our storage devices are still directly connected to a switch, but they are connected to a special high-speed switch known as a fiber channel switch, and that gives them their own dedicated high-speed network known as a SAN. And that solves the network performance related issues that we saw with network attached devices that are connected directly to our Ethernet switches. So the upside of storage area networks is that they're incredibly fast and scalable. The downside is that they're expensive and complex, and that's why you'll generally only see these used in enterprise level environments. Now, a couple of other things I want to bring awareness to that Microsoft has really innovated with over the last few years is software-defined storage. We have a couple of features here. One's called Storage Spaces, which is available in all editions and versions of Windows, and one called Storage Spaces Direct, which is really geared more towards the server and data center side of things. Storage Spaces allows us to create a huge pool from all the available storage from our physical disks. So let's say in my home computer, I have, how about 6 HDDs, and I want to create an E drive and a D drive. Once I create this pool, I have all of that storage combined into one. So let's say these were 1 terabyte disks. Now I have 6 terabytes to work with, and I can create these virtual drives, my D and my E drive, and carve out only what I need to create those disks. And it comes packed with all kinds of performance and reliability features as well. Storage Spaces Direct is the exact same concept, except that it's geared towards the data center and only works with server versions of Windows. In this scenario, we pack enclosures full of these cheap storage devices, HDDs and SSDs, to create armies of storage devices. Uh-oh, Neo, here they come. We get many of the benefits of all these other technologies we looked at without the complexity and the cost. So those are the many kinds of storage devices you'll be working with as a systems administrator. You'll also be managing the actual storage of those devices from the inside, carving out disks and volumes from the available pool of storage, and monitoring the capacity of those devices, because there's nothing worse than getting a phone call from somebody that you've ran out of storage on your server. Ugh. So we always have to plan ahead for that, monitor it, keep an eye on it, so we can add capacity before we run out. I hope this has been informative for you, and I'd like to thank you for viewing.